This video instruction should help you with the Chapter 3 Fundamentals of Algebra Q8. I originally did all the odd questions, made a YouTube video. It ended up being more than 15 minutes. When I tried to upload it, it would not work. So I'm going to make a quicker video and give you the solutions that I have for questions, the odd numbered questions on Q8. This is question number 1. It says that the drill draws a current of 4.4 amps, and it wants you to find the power in watts. The formula P is power in watts is equal to I squared R. I is 4.4. I squared 4.4 squared is equal to 19.36. Multiply that times 13 ohms, which is the R, comes up to 251.68. The answer right here, 252, is the correct answer. On question number 3, this is a formula for R value or insulation value, and it is the thickness and the thermal conductivity. Simply the thickness L is 1.5, and it tells you here that you must be in feet, even though it says 18 inches here. It has to be converted to feet, which is 1.5. The insulation value is 0.026. When you do the math here, it's 57.69. 58 is the correct answer. On number 5, volume, length times width times height is the way to find volume in cubic feet. It tells you that the cubic foot volume is 17,250. We're finding find the width. So we have the length and we have the height, which is 25 and 23. So in order to find the width, we take the volume divided by the product of the length and the height. 17,250 divided by 575 comes out to 30. Answer right here is width is 30 feet. Question number 7. This is Ohm's law. Hopefully you don't have any problems doing this, because this is one of the ones we use all the time. The formula V is equal to IR. I is 2.2. V is 5.73. If you're finding for R, you have to divide both sides by I, and when you do that, you end up with VI. The I cancels out here, so it's VI is equal to R, or R is equal to V over I. This is V, this is I, this is the result, 260. So the formula is for resistance is equal to voltage over amperage, and for this, with the values given, 260 is the correct answer. On question number 9, I'm not really sure what F, S sub I, and S sub O, I'm not sure what this formula is for, but we're finding for S sub O. And if you look at the formula here, in order to separate S sub O to one side of the equation, we'll have to subtract 1 over S sub I from both sides. That is 1/13 and 1/22. I'm going to do it by finding the decimal equivalent, subtract it, come up with a number of 0.03147. And then when you take 1 over 0.04137 in your calculator, you do 1 divided by that number, you'll come up with this number, very close to this answer, 31.8. For question 11, again, the same formula, and this time we're finding for F. So basically we're taking the value 1 over 27.5 and 1 over 38.5, converting that to a decimal, adding the two together, taking 1 over that decimal, comes up to 16, and there's the answer, 16 centimeters. Question 13, this is one of the questions related to, I wanted to make sure it was recording. It's related to Ohm's law, and this is the formula for two resistors in parallel. And one thing you'll always see is that when you have two resistors in parallel, the total resistance is going to be lower than either one of the parallel resistors. It will always work out that way. So in this equation we're trying to find for R2, we have to move R1 to the opposite side, which means subtracting 1 over R1 here. So the equation is 1 over R minus 1 over R1 is equal to 1 over R2. Do the decimal equivalent, comes out 2.083. Find the value of that is 12. Again, two resistors in parallel. This time we're given R1 and R2, so simply we take 1 over R1, 1 over R2, find the decimal equivalents, add the two together, take 1 over that decimal equivalent, comes up to 14.6. Question 17. This time we're finding for R2, which means we have to move 1 over R1 to the opposite side of the equation. That means the formula we're using is 1R minus 1 over R minus 1 over R1. Decimal equivalent of 1R, decimal equivalent of 1R, 1 over R1. Here's the result. 1 over that is 303.9. Here is the actual answer, 304 ohms. Question 19, again, now we've got three resistors in parallel, and again, the total resistance is given. All of these are going to be bigger than that number because the total resistance of 70 ohms, 1R or R here, is going to be smaller than any of these. So we know for sure that the when we find for R3, it's going to be bigger, higher resistance than 70. So we find the total resistance, and then we subtract the other two because we've got to move this 1 over R1 and 1 over R2 to the opposite side of the formula. So we subtract those two. We find that the decimal equivalent of the remainder is 0.00339, and we find that is 294.9. There is 297, so that is the closest, and that is actually the correct answer. Question 21, again, we've got three parallel resistors. It gives us the total resistance, which is 1 over R, and now we need to find for R2. We have to move 1 over R1 to this side, 1 over R3 to this side. So we'll start out with 1R, which is 1150 ohms, find a decimal equivalent, subtract the decimal equivalent of R1, and then subtract the decimal equivalent of R3. And the result is 0.000365. We do that, and it comes out to 2740. Pretty close to this answer right here. R2 is 2750 ohms. Final question. Now we have four resistors in parallel, and it's asking us to find the total resistance. So if we take the decimal equivalent of R, 1 over R1, 1 over R2, 1 over R3, 1 over R4, 1, 2, 3, 4, and we add those all together, we come up with 0.004387. When we do the inverse of that, we come up with 227.9, real close to 228. That is the correct answer. I hope this helps. I do want to spend more time going over formulas. In particular, I have formula sheets that I use for the STAR exam, and they're practical formulas that you will need to know. This will be the last new quiz for this semester. Next week we'll be going over, we'll have a review and then the semester final. So starting out, probably, I assume we're going to be online again in January. I want to get back into going over some more formulas. I think this is important that you learn how to work all the different types of formulas you're bound to run into somewhere in your career.